essentially the purpose in our project this summer was to determine how different options trading scenarios result in optimal outcomes under different market conditions. So we essentially looked at technical data from companies, and we looked at options prices, and we determined essentially which different combinations of puts and calls, which my partner will explain later, essentially results in the best possible outcomes for trading.
So just some background information. Our project, as you can tell, revolved around options and options trading. And so essentially what an option is a contract which allows the holder to buy or sell a stock at a certain price by a certain date. And there are two different types of options. There's a put option and a call option. And so what a put option does is it gives you the right to sell the stock, while the call option gives you the right to buy a stock. And so just for one example is right here, that is a Apple call option. And so say at this moment, Apple is trading at around $108. So if you look at the top portion, those are shaded in blue, which means those options are in the money. Meaning if you were holding those options at this moment, then you will be making money if you were to exercise upon them. And the ones that are lower are out of the money, so if you were to exercise them, you wouldn't be gaining anything. And so just an example is, if I bought this option for $108 right now, and then Apple released its iPhone 7 and prices skyrocketed to about $200, and I exercised that option at that moment, I would be able to buy Apple options for only $108, and if I wanted to, I could sell them to the market for $200. Similarly, if I bought a put option for this, then I would be buying it for $108, and say something faulty was happening with the iPhone 7, the stock price would lower, and if I exercise that put option, I would be buying the stock at a cheaper price, and then selling it back for a higher price.
Okay. So in this slide, we'll be going over a couple of different option strategies and how they relate to the scenarios my partner just talked about. So one of the first strategies that we can look at on the far left top corner is the long put. A long put is essentially when you buy a put option and you're holding that for a certain period of time and then selling it. And what it essentially allows you to have is this protection against infinite loss. So on the right-hand side of the long put column towards the right, so the axis essentially represents the current stock price, and the vertical column represents the amount of profit you're making or the amount of money you're losing. And so what it essentially prevents you from doing is making an infinite loss towards the right side of the column. You see that line would, if you were just to buy like a normal stock, it'll continue to slope downwards. Versus when you buy the put option, you see this plateaus out. What you lose, this loss that you have associated with this protection, is that at this point A, that would normally essentially be your break-even point if you were just to buy the stock, because that's the price that you bought the stock at. But with it, when you buy the put, because you have to pay a certain price to buy that put in the first place, you're losing money at the break-even price. Your break-even price is going to be slightly to the left, meaning the actual price of the stock has to be lower than what the current market price is for you to be able to be profitable in this scenario. So similarly, we have short calls, long calls, and short puts. Short calls and short puts are essentially similar strategies, but instead of buying the put now and selling it later, you're selling the put now and buying it up later, and then placing that where you would have to sell it. So it's essentially like shorting the stock. The ones that we have on the bottom are the iron condor and the iron butterfly. These are essentially combinations of different of the four basic strategies on the top, combinations of selling and buying puts and calls. So when you combine these in different ways, you can maximize your profits under certain market conditions. So these are some of the different strategies we'll be exploring in later slides.
So R programming is the language that we use to perform our project. Like SETA, it is a language and software environment which is commonly used for statistical analysis. And you can load packages from online to enhance the library of functions, allowing us to do a lot more different things. Using R programming, we loaded data, we analyzed it, we sorted them, and we were able to perform calculations to calculate the return, which we'll talk about later.
So in our, once we collected all the data in R, we had to use linear and logistic regression. So linear regression essentially allows us to, what it essentially allows us to do is to to find a quantitative output in the y variable, which is our essentially our return for the stock. And we have like a multitude of factors. We had about 25 different factors of technical data. We had stuff like the price 25 days ago. We had like a moving average, how the stock price is changing. We had the current price. So using about 25 or 26 different factors, we were able to create a model. So each one of these residuals that you see right here on this plot represents a squared residual, and then you square those numbers and you add them up. And essentially, the way that we generate this line is by minimizing that squared sum. And you can do this with any number of variables. So what's so powerful about this is you can take any number of input variables and result in a single output variable that determines your options price, and that will help us determine which strategy to pursue. Similarly, we have logistic regression, which we can also implement in R. So the slight difference between linear and logistic regression is that linear regression essentially helps us plot this y variable, but what logistic regression does, it just helps us classify between two or three, a few binary options. So we can either say a stock is gaining money, say in blue, or it's losing us money in red. And the way we generate logistic regression, we use a similar method to linear regression, but instead we plug into this logistic regression up here. And what it essentially allows us to do is classify a certain set of input variables into a single continuous discrete output variable, either A or B, blue or red. So what it allows us to do is essentially pick between two different options. So this is the code that we run in R. It's pretty simple. We don't have to actually go into all the little details. R simplifies a lot of stuff for us. We can just write LM and then add up all the different points in the data, and it will give us a linear or logistic regression model.
Okay, so the steps that we took during this project, we first began by choosing around 3,000 ticker symbols for companies that we wanted to analyze. Then we gathered options data from them using the Flipside R packages, which pulls option data from Google Finance, the website itself. Then we gathered technical data using QuantMod packages. And technical data is essentially the actual, the open and close of the actual stock price for the company, whether or not it pays dividend, how much dividend it pays, and other stuff like that. We then merged both the option and technical data, so that we could perform calculations on them and analyze them. Using that merged data, we then calculated the return based on different strategies that we used, which Rahul talked about earlier. We then analyzed the data and we calculated the linear and logistic regression. And using the coefficients that we found from the regression, we calculated and reported our error rate.
So some of the data that we're going to be looking at this set is essentially changing different variables. The one that we're going to be looking at is the number of days to expiration of the option and how that affected the error rate, how often we were able to correctly predict whether we're gaining money or losing money under this option trading scenario. So we mapped days to expiration on the x-axis here from 0 to 20, and we mapped on the left vertical axis we mapped the percent error, so essentially how far off we are in our predictions. And what we saw that in general, as we increase days to expiration, we have a positive trend of percent error. So essentially, the closer we are to the expiration date, the more likely we are to be able to accurately predict how the option is going to move up. So that's essentially a function of how much uncertainty changes over a longer period of time. Closer to the option trading itself, there's less variability, but that also means that there's less chance for profit. There's also less chance of losing money. So that's what we see in this graph here.
So we can implement our project into the real world in many different ways. One is options trading consulting. Consumers like you and I, we may not know that much about options trading and which options to buy, when to trade them, when to sell them. And so our program calculates return based on the holding period and the current stock price. If you paid attention to our graph, it isn't exactly very accurate at this point, but obviously after some refining, changing the code a little, we can lower the error rate, and customers can then utilize this program to then choose which options they want to buy, how they want to buy it, when they want to buy it, and which strategies they want to implement. This is essentially algorithmic trading, which is a process that is used in present-day stock trading, and essentially involves a computer to perform tasks at a speed faster than a human is normally capable of doing. And so by using algorithmic trading, we can use historical trends and return calculations to suggest optimal options strategies, and we can tell consumers that, hey, you should buy this option at this time and sell it after holding it for 15 or 20 days.
So now we'll be kind of discussing some of the conclusions that we made in our project. One of the first conclusions that we made is that using multiple technical indicators, such as the ones we discussed, like the moving average of the last 50 days or the current stock price, right? All these technical indicators are always numerical, and they can help us quantify how options will move in the future and how stock prices will move in the future. But at the same time, it's not like the same as just giving more analytical data, where it's more like looking at how the company is doing right now, what products are releasing in the future. So what we can do in order to make our model more accurate in the future is to include more of these different aspects of technical data, because the more different variables we use, the linear and the logistic regression systems can account for them and use all these to create a more accurate prediction. So if we're just using 1 or 2 variables, we'll have a less accurate prediction. The more variables we use, right now we're at 26 different variables. The more variables we use, we can have a more accurate prediction. So right now it's not like fully accurate enough, and some of those reasons are like not having enough variables. Some of the reasons are like some like small errors in terms of how we're actually processing data. Like if we're only looking at a certain company, or if we're looking at all Fortune 500 companies, or if we're looking at all the indexes on the NASDAQ. So like being able to narrow down our subset to specific companies can also help us in the future to provide more accurate data.
So just our takeaway from this program as a whole, we really enjoyed SIP. We had a lot of fun doing it. One of the things that we learned was problem solving and researching solutions. The first day we met Samay, our mentor, he actually discouraged us from coming to him with our problems, and he told us that he'd rather we go to Google to find our issues. So because of that, we became really familiar with forums such as Stack Overflow, because we realized that if we're hitting an issue right now with our code, chances are someone else out there has the exact same issue. We also learned a lot about statistical analysis. Rahul discussed linear and logistic regression. When we first entered this program, we only knew basic statistics like mean, median, mode, standard deviation, that kind of stuff. But this program really helped us enhance our statistical knowledge. And finally, we learned a lot about team collaboration and enhance what we already have. Rahul lives about an hour, hour and a half, depending on traffic away from me. And so we had to find free time to Skype each other. We communicated over Facebook Messenger, email, and other stuff like that.
The last thing we want to do is make some acknowledgments for the program. So one of the first acknowledgments we want to make is for our mentor, Samay. Samay helped us a lot with this project. At the same time, like my partner mentioned, he showed the restraint to not like spoon feed us every piece of information. That really helped us gain these like real world application skills that we wouldn't have if he had just kind of led us down every step of the path. So we really appreciate that. The next acknowledgement we want to make is to the UCSC campus, the school as a whole, for hosting this program. It's a very like valuable program that we will definitely be using in our future skills. It definitely has like helped us shape ourselves as like researchers and stuff like that. So we want to extend our thanks to UC Santa Cruz.
We'd also like to thank our parents, because this was not only a financial obligation, but also took a lot of time out of their days. Whether it was driving us to the bus stop or sometimes even all the way here to Santa Cruz, they were always very supportive of us and helped us whenever we hit issues or were very frustrated. And finally, we'd like to thank all of you for coming and watching us today. We had a lot of fun, really enjoyed this program this summer, and we're glad that you were here and allowed us to share what we've learned with you today. Thank you.